Hello everyone. This is Sarvahita, Assistant Professor of MCA Department of Brownie College of Engineering and Technology. Here we are going to discuss a topic called interaction diagram, sequence diagram and collaboration diagram. First, let us see what is UML interaction diagrams. From the term interaction, it is clear that the diagram is used to describe some type of interactions among the different elements in the model. So this interaction is a part of dynamic behavior of the system, and this interactive behavior is represented in the unified modeling language by two diagrams, that is sequence diagram and collaboration diagram. So both these diagrams comes under interaction diagram. The basic purpose of both the diagrams are similar. The sequence diagram emphasizes on-time sequence of messages, and collaboration diagram emphasizes on the structural organization of the objects that send and receive messages. That is, sequence diagram will send only the sequence of messages, and this collaboration diagram will have the impact over the structural organization among the objects which send and receive the images. The purpose of interaction diagram to visualize the interactive behavior of the system. It is a difficult task because the solution is to use different types of models to capture the different aspects of the interaction. The sequence and the collaboration diagrams are used to capture the dynamic nature but from a different angle. The purpose of the interaction diagram is to capture the dynamic behavior of the system, to describe the message flow in the system, to describe the structural organization of the objects, to describe the interaction among objects. We have two types of interaction diagrams in the UML. One is the sequence diagram and the other is the collaboration diagram. The sequence diagram captures the time sequence of the message flow from one object to another, and the collaboration diagram describes the organization of the objects in a system taking part in the message flow. The following things are to be identified clearly before drawing the interaction diagram. Objects taking part in the interaction, message flows among the objects, the sequence in which the messages are flowing, and the object organization. The diagrams show the sequence diagram. It has four objects: customer, order, special order and normal order. The following diagram, which shows the sequence for the special order object, and same can be used in the case of normal order object. It is important to understand that the time sequence of the message flows, and the message flow is nothing but a method call of an object. The first call is send order. It's a function which is a method of order object. Next call is confirm, which is a method of special order object, and the last call is dispatch, which is a method of special order object. Now let us see about the collaboration diagram. The collaboration diagram shows the object organization, and it has a method called sequence which is indicated by numbering technique, and it is also called one after the other. We are taking the same order management system to describe the collaboration diagram. The method calls are similar for the sequence diagram. However, the difference between them is to describe the object organization, whereas the collaboration diagram shows the object organization. To choose between these two diagrams, emphasis is placed on the type of requirement. So in time sequence is important in the sequence diagram. For organization is used, collaboration diagram is used. So this is the diagram which shows the collaboration diagram. The interaction diagram can be used to model the flow of control by time sequence, to model the flow of control by structural organizations, for forward engineering and for reverse engineering. The sequence diagram has the following scenarios: a broken line with the unfilled solid arrowhead which is drawn from the class, and then it defines a functionality that implements the function. When in the case of identifying the state and behavior, the object which it belongs should be noted. The behavior and identity. We can model the states of the system by defining the states of the object to represent it. Sometimes they act as the object, or sometimes they act as themselves. The ways in which the object behaves are determined by its operations. The object needs to act as another object to retrieve data. For instance, it uses an operation. An operation occurs when a message is passed between the two objects, allowing some function to be performed. for structural and security reasons, some operations and attributes in a class or object are not visible to other classes. The three most common types of operations that a class can have are modifiers, selectors, iterators. Modifiers A modifier operation alerts or alters the state of an object. The selector operation lets you to access the state of an object without changing it. Iterators operation allows all the parts of the object to be accessed in a definite order. Object-oriented programmers often create a separate class that is responsible for using the iterator function of an object. Modifiers, selectors, iterators are not a part of any programming language but are used to characterize the effects operations have. There are two types of operations which need to be create and destroy the instance of a class, that are constructor and destructor. The constructor operation creates an object and fixes its initial state. The destructor operation destroys an object. Thank you.